Hi everybody. Today what we're going to work or go through is going to look a little different. What you should have in front of you as you work through today's lesson is going to be like a 6-page, so like 3 pieces of paper back to back, that's going to have like station A, station B, all the way down to station F. You want to take those notes for today, and we're going to tackle something in a little bit of a different way. That what today could be for you is complete review from last year. And so you may start to look your way through some of these diagrams and it might come back to you pretty quick. And all we're going to be doing today is adding in some terminology. For others, this is a brand new topic to you. Don't worry, we are going to cover it as if it is a brand new material or a topic. And so some of the stuff on the page, as you see, is going to be completely new for you. No worries. What you're going to do is you're going to take a look at each page and do not worry about filling in this top section. We're going to put a name to what each of these stations represent. What you're also going to see then is a diagram and a solution. So I've given you a diagram in the first one, and I've told you what the value of P is. I've given you a diagram, and then I've told you what M is. Those are your if statements. So if this is the case, and if this is the case, then can you draw conclusions about the rest of those diagrams? So that's what we're working on today. If the blue is the case, and if the red is the case, then if we look down at the bottom, can we figure out what the value for N would be in that diagram, or the value for W in that diagram, so on and so on. Now, you're going to do that for all the stations. So then you're going to turn over and you're going to work on B, and then you're going to go through that same process. I'm going to now scan down to the bottom of B. Don't worry about filling in this bottom section at all right now. So on each page, even multiple times on some pages, you're going to see how do you know this and some blank lines. We're going to fill that in together with some new terminology perhaps. Okay? Your job is to go through those 6 pages. Now, if we were doing this all together in our room, I would actually set up 6 different stations and we would rotate through those 6 stations. I'd actually set the timer for about 1.5 minutes at each station. So what I want you to do is to actually try to push yourself, like go pretty quickly, put a little bit of pressure on, see the if statements on each page, and try to draw a conclusion then about what should happen for any of those problems where I didn't give you the solution. Can you take what you see in the if statements and can you apply them to the then statements? Okay, so when we come back, we're going to go back to page A, station A, and then we're going to go through and we're going to fill in some stuff together and we're going to talk a little about some theory along the way. Okay, so I want you to pause the video now and work through all 6 stations. Okay, good luck. Okay, and so we should be back and we should have all 6 stations completed. Okay, all 6 stations completed. And so if we want to jump into station A, then we should see that we had our if. Okay, if I look at that first one that I'm going to highlight in blue, I have this angle of 110. That's angle P. P in this case is 70. If I have this angle of 94 and this angle of M, M was 86, then I'm hoping that we were able to go through and draw a conclusion in our purple. That therefore N must be 65 degrees and W must be 117 degrees. And if I was to slide that up a little farther, then we would also come to find that angle V was 45 degrees and angle C was 109 degrees. So hopefully our values match up and we're able to come in with those values on the 4 problems that we were able to come up with what that pattern was. So what I'm going to do is just kind of scroll down a little bit. What we should be filling in at the top of station A then, station A represents co-interior angles. Now, in terms of us working through that, I would doubt that very many of us, if we saw this stuff last year, went, oh yeah, that's right, this is our co-interior angles, that we probably didn't come with that terminology. However, if we scroll down to the bottom of the page, I'd like you to get that down. So what you see in red is basically how we knew that angles contained inside parallel lines add to 180 degrees. Now, I want to go back up and we're going to take a look at those 4 problems that you hopefully came up with those answers to. And I'm going to shade in a little bit some of that information. So if we notice, we have a parallel line and a parallel line. I know that those 2 are parallel because I see my arrow markers on there. And notice that this line that crosses them, that line is referred to as a transversal. And if we notice that that transversal, if I now highlight it in blue, causes my angle N and my 115 degree angle to be contained inside the parallel lines. Now, take a look at my next diagram. You'll notice parallel line, and now when I put on my blue transversal, I get my angle and my other angle. So the 2 angles contained inside my parallel lines. Now, if I was to get rid of some of that shading, and I only focused on the angles on the same sides of my transversal. So even if I was to shade that in now on the next diagram, parallel line, transversal, parallel line, transversal. And if I was to even go back to the first 2 and really clean up that diagram, then we should be able to see why we often think of co-interior angles as C pattern. So my guess would be is that an awful lot of you would have learned that being called C pattern. And you notice that what you have in that red highlight everywhere just happens to be like the letter C, but rotated. And what do we know about the angles contained in C pattern? They add to 180. So what you'll see for your justification on some problems will be what you see in blue at the bottom, that C pattern, in blue at the bottom, C pattern will be written out, there's your justification. Or sometimes you also see the green written down. And what the green represents is a little acronym. The PLT stands for Parallel Line Theorem. And then you see the dash C just to represent C pattern. Okay, hopefully station A went okay. And now that we can see how we can use those pages, I want to give you another opportunity. So maybe you feel a little more confident now that there may have been some spots at some other stations that you were a little unsure of that you might want to go back and give another shot to. So if that's the case, then I want you to pause the video and go back and try to work your way through those. Otherwise, we're all going together onto station B. So, station B should have been a case where we saw that we had opposite angles. So we should be filling in at the top. Station B are all examples of opposite angles. And instead of us copying the bottom down first, I want to take the other direction now. What are opposite angles? Well, if I take a look at opposite angles, if I have a line intersect another line, then what that always does is it forms four angles. I get this set of opposite angles in red, and I get this set in green. And what you would have seen then is that my B value equals 56. Sometimes those opposite lines, those lines that intersect, happen within part of a bigger diagram. This line intersects this line, and that created four angles, of which this set, this line angle equals this angle. And so hopefully then we were pretty quick to be able to go through those next four problems, and I'm just going to shrink that down and move that up. That we were pretty good to be able to say that angle D is going to be 84 degrees, E 130, G 73, and F 125. So hopefully that matches up then, and we're pretty good with our opposite angle theorem. So I'm just going to slide that up and make that a little bigger so we can get down our theory on the bottom. How do you know this? When two lines intersect, equal angles are formed. And so when you have to go through and quote, when you have to cite what theory you use to be able to get that, you can just write down OA. So if I was to go through and answer that problem above for G, I can just write 73 degrees, and beside it, I'll write OA to explain how I got that. And your reader will then understand, oh, okay, so you used opposite angles. There we go. Hopefully not too bad. Let's jump on to station C. Okay, so station C is going to look a little different because we actually had two different properties on that page. However, they all fall under the category of interior angles of a polygon. So really what we're talking about is the interior angles of a shape. So the name that we used was interior angles. That's what you see in purple. I added on of a polygon at the end because it depends on what type of polygon. So for instance, is it a triangle or a quadrilateral, so on and so on. So what you saw up on the top, in your first case, you saw, well, if I have a triangle, two of my angles were 55 and 75, then the third angle was 50. In the next triangle, you found if two of your angles were 143 and 7, then the third angle was 30. And maybe that brought you back to your piece of theory that all the angles inside of a triangle have to add to 180 degrees. So we should be getting that down in the middle of our page. Now, what you'll see in green is a very official way of stating that. That is the interior angle theorem, and then the last T represents for a triangle. And so, if I needed to come up with what X was, then we should have found that X was 47 degrees, and you could just quote on that triangle. You don't have to write IATT, just draw a little triangle. Your reader will understand what you used. So the same thing on Q. Q, we should have come up with 110 degrees. So I just want to go back to X to make sure that we are good on how we got that. we could take 180 and subtract the sum of the other two. Subtract off your 13, subtract off your 120, and there we go. Okay, let's move down to the bottom of that page, and I hope that we can recognize that all we did was just change shapes. And maybe then we saw a different property. Now, I didn't give you any answers for down below, and so as you work your way through, there was probably a lot of hesitation. But as you did complete that, I'm hoping that we were able to use what we know about the quadrilaterals that we are most familiar with. Okay, what do all the angles of a rectangle add up to? What do all the angles of a square add up to? And if I then started to take my square and tilt it and form a rhombus, notice that I have these smaller angles now that are less than 90, but I created these bigger angles that are bigger than 90. My sum will still be the same. And so as we worked our way through, I'm hoping that we were able to get down to an angle on M of 100 degrees, an angle on N of 100 degrees. And I hope that we didn't put an idea in our mind that all of a sudden everything had to be 100. And if we were to work our way through, we could see that in S, the next one, that I need to take 360 and subtract the sum of the other three angles. That all my angles inside of a quadrilateral work out to be 360 degrees, and so we get a little confirmation on the end. And so for all the same reasoning as what we had before, how do we know that? Because the angles in a quadrilateral have to add to 360. And there in green is your official way to quote it, interior angle theorem for a quadrilateral. Or give me your answer and draw in a little box afterwards, and your reader knows what you used. Okay, let's keep it going. We're jumping into station D. Okay, what we have then in station D are examples of what's referred to as corresponding angles. And the same thing as earlier, I don't think too many of us would really remember this one as corresponding angles. But rather, we might remember it a different way. Now, I actually think that coming up with the angle measurements is pretty straightforward. We see that the first one gave us 95, the second one gave us 75, so hopefully we were able to say that x would be 60, and then in this diagram, x would be 100. And if we were to shrink it down, then x is going to be 55, and x is going to be 87. And so we have these four examples of how I have equal angles in some different positions. Okay, how do we know that? Well, I want to draw to your attention first the definition. So I'm going to slide that up. And so we should be able to see just the definition on the bottom of your screen. What do we have in all four of those diagrams? We actually have a situation where we have angles that are both above or both below. So I'm actually going to put some commas in here. Angles both above or both below are parallel lines and on the same side of the transversal. And what do we know about those? We know that they're equal. So what I'm going to do is I'm going to take those words at the bottom of the page and I'm going to draw exactly what they have on each diagram. So let's highlight the first one. It says angles both above or both below the parallel lines. So I'm going to highlight the parallel line that forms each angle. Now notice that angle X and 60 degrees are both below the parallel lines. Now, if I highlight the same side of the transversal, so I'm going to highlight the transversal, that has included now both angle X and angle 60. That some of you guys might now remember why we often refer to corresponding angles as the F pattern. You can maybe see your backwards F. I'm going to do the same thing on the remaining 3 diagrams. If I go, both my angles are below the parallel lines, and to the right of the transversal, then we can clearly see an F in that second diagram. Now, I chose to put in the words both above or both below just to avoid some confusion. But really what that definition says is angles that are both on the same side of the parallel lines and on the same side. I just thought that we might have got a little confused about seeing same side written in several spots. Take a look at the third diagram, our 55-degree diagram. If I was now to highlight parallel, parallel, notice that my X and my 55 are both on the same side of the parallel line. They're both on the left of it. And now, if I highlight the transversal, you can see that both those angles are below it. So both of those angles are to the left of the parallel line and both are below the transversal. They're on the same side of everything. You can see your F pattern. To the right of the parallel line, to the right, and both below. That what we have now on that page is a series of rotated Fs. So the formal name for F pattern, corresponding angles, because the angles are on the corresponding sides of the transversal and parallel lines. Okay, hopefully that one went well, and now we're jumping into station E. Yeah, okay, station E probably looked a little different to you as well, because we have 2 sets of properties on that one page. So what you see up at the top is we have complementary or supplementary angles. And so maybe we took a look at that first diagram and we notice that if I have X and 55 inside my 90-degree angle, then X has got to give me 35. That maybe we saw that in the second diagram, all the way around is 180 degrees on a straight line. And so if one of those angles was 55, then the other one must be 25. And you can really see that property when you take a look at the third diagram. I have a straight line broken up into 2 angles. One angle, 85. My other one must be 180 minus the angle I know. And so hopefully we use those to be able to get through our then portion of our page. And so as a quick check, we should have been pretty good to be able to get 40 degrees for X on the first diagram. Pretty good to be able to get, okay, well, I've got 75 and 75 for both X and Y on that second diagram. Okay, why? Well, if I was to look at this straight line is broken up into 2 angles. It's broken up into angle of 105 and angle of X. So x has to be 180 minus the angle I know. Now, maybe you did y first because you looked at y and said, yeah, but this straight line is broken up into two angles. Angle 105 and angle y. And so maybe you said angle y has to be 180 minus the angle I know. Who knows? Maybe you actually looked at it and said once you knew x was 75, then you know that x and y have to be equal because of opposite angles. Okay, we take a look at that third diagram. Now in our third diagram, we should have got that y is 55 degrees. And in the last one, we should have got 105 degrees for x. Okay, if we've got that, then it's just time to get down some formal statements. Okay, what do we know? Well, angles that add to 90 degrees are called complementary angles. And angles that add to 180 degrees are called supplementary angles. And so you see their two short forms afterwards in blue in the brackets. And so just as we used OA for opposite angles, or we'd write down like C pattern or F pattern for others, for this, you're just going to quote them using CA or SA for complementary angles or supplementary angles. Okay, time to jump into our last station. And so what we had for station F, we should be able to get down the formal name for it. It's a case of alternating angles. And for those of you that have addressed this topic in the past, this one seems to be the one that you guys remember the most. That if we saw in the first diagram, you have your 37, we saw in the second diagram, well, I didn't even give that to you because my guess is we could have worked that out and got our 90 degrees, just even off the one diagram. Then we could probably sort out that that next diagram would give us a case of 122 degrees. And our last diagram, our value of K being 75. Okay, I want to tackle this one a little bit different. What I'm going to do is I'm going to create my shape based on my diagram. So what I'm going to do is I'm going to contain all my angles. Okay, this angle of 37 is formed there. This angle of X is formed there. And some of you guys probably remember the other way that people think of alternating angles. I can do it again on my next. My angle of 90 was constructed there, the parallel line, the transversal. My angle of Z was formed parallel line, transversal. And maybe we're even like rotating our page right now to be able to see the kind of shortcut name that we have. Maybe we're just getting confirmation on parallel line, transversal, parallel line, transversal. And now we got like a backwards version there. And I don't know what the last one is. Is it backwards and side? Parallel line, transversal, parallel line, transversal. That hopefully we were good to be able to go through and address how we got that. Notice that in all four of those diagrams, what we have is we have a pair of angles, so the angle pair, that are on alternate sides of the transversal and contained by the parallel lines. So in case we're struggling to see that red in the diagram, I'm going to just take the very last diagram to walk through. That statement says that the angles that are on opposite sides of the transversal. So notice if I highlight my transversal, angle K is below it, angle 75 is above it. So opposite sides of the transversal. And now I need to contain it in my parallel lines. So I have to make sure that those angles exist between the parallel lines. Notice that we just drew our Z pattern. And so if I was to jump back to that green diagram, we may see that red statement. Okay, what I need alternate sides of the transversal. So 122 is to the right of it, A is to the left of it. Now I have to contain it in my parallel lines, so I need it to be between them. And you notice that we get what looks like an S or a backwards Z. And so what you see in blue then is all you need to be able to quote. Just quote Z pattern anytime you're using that and we're good. Okay, today should have felt like a little bit of a different lesson, and that was good. That we were able to take some stuff that may have been in our background and just revisit it a little bit. Or for those people that swear they have never seen any of these parallel line theorems or polygon angle properties, that we were able to go through and get a pretty good head start on them this year. Okay, your job is to jump in on your worksheet, get some practice done using these things and making sure that we can find missing angles on diagrams. Okay, good luck with your practice.